Okay, thanks for having me here, and thanks for being here. And in case you are expecting Anand for some of you, I apologize. He couldn't. He was originally supposed to present, but he couldn't attend, so I came instead. Okay. So I'm this guy here. So this paper is going to be a little bit different from the earlier papers we saw, in the sense that probably because I'm coming from a macroeconomist point of view, right? And I'm trying to ask a micro question that is kind of relevant for me. And what's going to be specifically different is that we're going to look at the parents' effects on children's outcomes, but we're not going to really look at the parental choices and how they're endogenously formed. But we're just going to take parents as a state and look at how they relate to two types of children's outcomes, which is going to be the children's education and earnings. Okay? So we're going to just go after a very specific question here. And that question is just going to be, if I forcefully increase parents' education by a year, what impact is that going to have on the children's schooling and earnings outcomes? Okay? And this is motivated by the previous empirical evidence that the simple reduced form evidence that parental schooling has a large effect on children's schooling and earnings. Right? And then as an economist, the question you always ask is how much of this is selection and how much of this is treatment. Right? So what we're going after is sort of a treatment effect or a causal effect, right? And separately from selection. So this coefficient is positively significant no matter which time period you look at for many different countries and for many different data sets. Right? So it's a pretty robust thing that you see that highly educated parents tend to have highly educated children and also children with higher earnings. In order to answer this selection versus causal effect, the empirical literature usually makes use of these special data sets. Right? And some people already mentioned in the earlier talks, right? You used special data sets of twins, you look at adoptees and biological children, and a large literature looks at compulsory schooling reforms. Right? And this literature is kind of what our paper is going to be most closely connected to, in the sense that what happens if you forcefully increase parent schooling by a year or X years. But most of these papers find that actually the effect, the IV coefficient of the parent schooling on children's schooling is 0 or even sometimes negative. Right? And a lot of these find, and this is sort of deemed to be a puzzling outcome because you do find positive effects on other children's outcomes such as earnings or other non-cognitive traits. But for education, it seems to be in a large set of studies which use different approaches, just close to 0 or negative. Okay? Probably, at least if I just think about education and earnings, the reason that it seems puzzling is because we tend to think that education and earnings should be positively correlated. Right? We know that at the individual level, forget about parents for a second, if I just regress earnings on education, it has a very, very strongly positive explanatory power, right? Which is why it's probably deemed to be puzzling. So what we're going to do in this paper is kind of look at an individual life cycle earnings model. We're going to feed in parents as a state into that model and just see what's going to happen into the children's endogenous schooling choices and also the endogenous earnings outcomes when we change the parents without changing anything else in the environment. Okay? So that's basically the outline of the story. And basically what we want to go after is that it's important to differentiate the length of schooling that a child is going to choose endogenously. Right? So what's important is that the model has to be a model in which schooling can be chosen endogenously. It can't be where I just assume you either go to college or not or something like this. But that effect, the parental effect on the length of schooling can be different from what I'm going to call a quality measure. Right? And I think someone brought this up earlier, in the sense that even conditional on the same years of schooling, your level of earnings can differ a lot depending on your parental state. Okay. So basically, that's the idea. The outline of the talk is I'm going to build a stylized Ben-Perez model. Parents are going to be initial state, and they're going the optimization problem is just going to be to maximize lifetime earnings. Yes.
You separate the two questions. More educated parents have more income, and also more educated play a role in motivating the education of the child. Can you separate this?
Can I separate income versus motivation?
What's in dealing with the impact of education of the parents? There could be two different channels. one channel is that educated parents have higher income.
Right.
Another channel is that they are a role model to their children. They influence the children.
In terms of like some non-cognitive effect.
In variety of ways.
Right. No, so actually,
but it has nothing to do with, it's not directly something to do with income.
right. No, so actually it will turn out to be important. That's actually one of the main results of the paper, is that it's not so much the effect on the parent's income, but the effect that the parent might have on the child's the effect that an increase in the parent's education might have on the non-cognitive environment that is independent of economic earnings ability. Right? So that's going to be actually the main driver of breaking the difference between education and earnings outcomes. Okay? Sorry, where was I? Right, so the outline of the talk is just going to be, I'm going to show you the stylized model. It's actually a very simple model that's just based on a very simple idea. Right? However, based on the model assumptions, I'm going to show you that these assumptions are not invalid in the data that we use, which is going to be the HRS sample matched with Social Security earnings data. Okay? And then I'm going to include in a very stylized model what I'm going to call taste heterogeneity. This can be just considered to be some kind of preference heterogeneity or some kind of non-cognitive traits that Yoram just mentioned. Okay? And with that estimated model, I'm going to do some counterfactuals where I exogenously change the mom's years of schooling while controlling for other things in the model, right? And see what the effect on children's education and outcome is going to be, education and earnings is going to be. So if you forget everything I say afterward, this is just basically all the important results from the paper. Right? Now suppose I have my sample from the HRS, and I just exogenously increase the mom's schooling by 1 year forcefully. Right? It will increase the present discounted value of lifetime earnings by 1.2%, but it's going to actually decrease schooling by a little bit less than half a year. Right? So this is corresponding to the IV experiment that I told you earlier in the previous empirical literature. Okay? So and this is the sense in which, right, a controlled increase in parental schooling can have a negative effect on schooling, but still a positive effect on earnings. Okay? So then in the end, I'm also going to do a similar thing as here. Right? It's just going to be a parallel experiment. Instead of increasing years of schooling by 1 year, let me just finish this one point. Instead of just increasing schooling by 1 year, I'm going to impose a minimum years of schooling on all the parents and see what happens, right? So this is just going to target only those parents with lower years of schooling. In that case, the schooling will still decrease by 1/5 of a year, and the earnings increase will be larger. Yes?
What's the mechanism behind the drop in schooling by 0.4 years?
That will be very clear at the first slide of the model.
Okay.
So just give me a second. Right, and then again, this is the last thing that Uriah mentioned. So then why, given that the model seems to say that increasing parent schooling drops child schooling, why do we observe a positive relationship in the data? Right, that's all going to be something that is non-economic. It's going to be the effect of parents' education on something that is not related to earnings abilities. Okay, so there's a large literature that's related. Obviously, I'm not going to go through all of them, but like I said earlier, although it's kind of macro-motivated in the sense that we want to see what the effect of increasing parent schooling is going to be on the next generation and the next generation and so forth, right? The kind of most comparable literature are these three strands of literature that look at twins, adoptees, and compulsory schooling reforms.
Is Angrest and Kruger related to your first one?
This one?
No, your previous slide. There, point 1.
In the...
Oh, never mind, maybe it's not.
Oh, you mean the causal...
Well, I was just kind of thinking that they're looking at when you enrolled in the school year.
Right.
And like affected.
Right, no, it's exactly, so you can see from the title, it's all kind of exactly parallel to that empirical experiment where,
Yeah, that's right.
So the labor literature has looked at what happens if you forcefully increase an individual schooling by 1 year, what happened to that same guy's earnings, right? But now the question is instead, what's going to happen to that guy's earnings if you increase the parent schooling by 1 year, right? So it is very related. Yeah. Okay. So as I said, the model, sorry, Dawi, it's going to be the second slide, not the first slide of the model. Okay. So the model is pretty simple compared to the earlier talks, and I think as Mehmet mentioned in one of the papers he cited by me, like we're going to continue to ignore fertility and marriage effects, right? Since parents are just going to enter as a state, right? So parents enter as a state here, just I'm going to denote that, excuse me, as HP. This is going to be a stand-in for parental schooling or parental human capital. Okay? And the Z is going to be a child state, which he's just endowed with when he's born. Right? This is going to be a child's learning ability, basically how fast he is in accumulating human capital. Okay? So now a child is born. What does he do? He's going to earn, he wants to maximize a sum of his present discounted value of lifetime earnings and a non-earnings component. Okay? So this is going to be the, you can call it a taste for schooling, a non-pecuniary benefit, or whatnot. Okay? So this is the basic setup of the model, and for now, I'm just going to focus on what here is called V tilde, what the problem of maximizing present discounted value of lifetime earnings is going to deliver. Okay?
So the parents don't have a learning ability.
The parents don't have a learning ability, no. So there is, so some parts of this model is motivated by the data that we use because it's restricted. We're using the HRS, so there we only observe the parent schooling levels actually. Okay? But I'll explain why we still insist on using the HRS. Okay? Right, so the present discounted value, the problem of maximizing present discounted value of lifetime earnings is very simple, and probably most of you either have solved it or know what's going to come out of it. Okay? So technically, you're just maximizing your lifetime income from age 6 to R. Right? So this is basically very similar to the original problem posed by Ben Perath in his original paper. Right? But you can find the optimal stopping time S, during which time you're just investing your entire time in school, which is denoted by N. So N is equal 1. That's why you don't see it here. Right? And only spending money on school, which is M. Right? So that's going to be a cost. And that period you spend up to 6 plus S is going to be a schooling period. And afterward, right, you're going to work, right? During which you generate earnings according to the level of human capital that you're currently holding and how much time you spend not accumulating human capital. Okay? So this part is pretty standard. Right? And the human capital production function is also pretty standard. It's just Cobb-Douglas with decreasing returns in both time and money, right? Where M is money and N is time. Okay? And the coefficients alphas are going to just sum up to less than 1. So what's important here is that the parents are just going to enter as initial state. It's all loaded into this H6, the level of human capital that I start with at age 6. Okay? So B is just the level controller for estimation, so you can forget about it for now. Right? So we're going to assume that the initial level of human capital is a function of the child's learning ability and the parental state, right? With some Cobb-Douglas form with exponents of lambda and nu. Right? So what I call a spillover is going to be referring to this parameter nu. Okay? And the causal effect of increasing parent schooling is going to all come through increasing the HP here and how the increased component of HP to the nu affects this optimization problem. Okay? So it's very simple, and that's it. Okay? Okay. So again, I'm just for now I'm going to only focus on the problem of maximizing the present discounted value of lifetime earnings. Right? So for a moment, just forget about the non-economic part. So forget about the taste for schooling, and also assume for a second that notice here that I assume that the human capital production function for schooling and working are different, but for a second I'll assume that they're the same. Right? And that just allows me to get some analytical results. Okay? So the analytical result is found just by solving an optimal stopping time problem, like I said, right? Where the optimal stopping time is going to correspond to the schooling time. Right? So I'm not going to go to the steps of solving this, It's just a lot of algebra, basically. And the result is going to be that S is pinned down by this one equation here, where f is some function. There's just some weird function with a lot of integrals. Okay? So it's going to be pinned down by equating the log of this function to a linear function of log z and beta sp, right? Where this is basically log hp. Okay? So again, since I don't observe in the data the parents' earnings and schooling separately in the HRS, right? I'm just going to take parents' human capital log HP to be equal to beta SP, where SP I do observe in the data, right? And we're going to separate the beta coefficient separately from the parent generation of the HRS, okay, for which we do have data. Okay. So then this is pretty easy. This is why we get the negative effect, the question that we asked. If you ever solved a life cycle earnings maximization problem, actually you know that if you increase the initial state, right, you're going to decrease the amount that you invest, right? And this is basically where the negative effect of increasing parents' schooling on children's schooling comes from. Okay? But that, of course, that doesn't mean that it's bad for the children, right? Because the children are optimally choosing to cut back on schooling, right? Because they don't need to waste time trying to increase their earnings later, and they can just right away enter into the labor market and generate a higher level of present discounted value of lifetime earnings. Okay? Now, if you look at this equation, right? So f is kind of a weird function, but just take my word for it that it can be kind of first order approximated by a by a linear function of s. Right? So this looks like a schooling intergenerational schooling regression, right? You can just look at child schooling and regress it on parent schooling, right? But of course, this z is going to be correlated with parent schooling, okay? So this is the child's learning ability. Okay? So since this is not independent, right, we cannot just run this regression and say that that coefficient is the effect of parent schooling on children's schooling, right? And that's the classical treatment selection problem that people have had in intergenerational schooling regressions.
You don't have different quality of schooling, so I mean, shutting that down seems like a big problem with this kind of model. You can't have different quality of schooling. You know, all of us in this room went to very fancy schools. Not just the years of schooling.
Right.
And you don't but you don't have quality at all.
Well, that would be the human capital H.
No, quality of schooling.
Right.
The kind of school you actually go to.
Right. So I don't have like you choosing different schools and this kind of thing. So if you go to the school for the same length but have different earnings, it's all going to be because of your individual state. It has to be embedded into it.
Yeah, but I mean, I understand that. I don't understand how you can make these strong statements, given that educated parents, the quality of schooling matters. So I don't see how you can write down a model and shut that down and then somehow skew and then say things about, having less years of schooling. I think those are very strong statements.
The quality.
What's the rationale for shutting that down?
The quality of schooling for the parent, or?
No, for kids.
So why? So for the same length, independent of the individual states, have a different qualities, right? That's what you're.
Why don't you allow them to choose the quality of schooling that the kid attends?
And quality can also mean, if I may, not just the school, the ranking of the school in some arbitrary sense, but what classes they do. Do they do basketball, weaving, or do they do engineering, or do they do mathematics? That makes a huge difference.
No. I agree that you can, of course, it would be ideal to build in many more dimensions of different qualities of schooling, right? And actually, Jeremy told me that last time also. Right. So I mean, the general message is not going to change, which is why we kind of dropped it here. But it would be an interesting dimension to look at. But for that, we also don't really have the data. I mean, if you want to do that, you really have to focus only on that dimension, right?
Sorry? Would it matter for interpretation if you said that if you go to like an Ivy League school, then just getting a BA is sufficient to enter into a really good career? But if you don't go to an Ivy League school, you need to get a master's degree to signal, right? Mm-hmm. So the interpretation, it could be that a lower amount of education is sufficient rather than they it's a complementarity between their unobservable quality and education.
So I didn't really, is that just comment or?
I'm just saying why it could matter, because you said why would it matter, and it could matter for your interpretation, because you're interpreting it as saying they don't want as much schooling because they're so high quality already. And I'm saying it could be that
with a
if
signaling
they can
component.
get into a higher quality school, they don't need to
Right.
get a master's degree to signal.
Right. I mean, there are, again, many dimensions we're ignoring, right? The kind of what we're adding to the previous literature is actually, even just thinking about the quality dimension instead of just regressing years of schooling on years of schooling, right? But of course, there's still a lot of things lacking. About the signaling component, I actually do believe that a lot of education is just for signaling, right? Even though this model is written in a way that it's just purely all human capital accumulation. I have to think about how you would actually build that into here. But one thing is that we are looking at the HRS sample. And these are really, really old people. Right? So I would think that at least for the generation, like 2 generations ago, it was maybe less relevant than today. Right? Because back then, like, people were barely going to high school, right? Or things like this. Okay? But it's a point well taken. Okay. I have to
In your favor, of course, you'll be looking at the compulsory schooling margin.
Right, exactly.
I don't believe there's going to be huge heterogeneity in the type of school that people are going.
Right. No, it's very low.
The decision is to go
Right.
one extra
Right.
part of
I mean,
the year after 16.
so for that particular experiment, yes, it doesn't really. These are probably less relevant.
Yes.
But if I want to get an average effect of
course,
increasing,
I'm
that's
just saying
that's
that
true. Yeah. Okay.
Numerically, it might not matter very much.
Right. Yeah.
Can you separate the data
okay.
question?
Right. So,
Can you
base.
separate into data if you are Chinese origin?
Do I
Can you separate into data
the races?
if you're, say, Chinese origin?
Yes.
You
So we do have the
that?
ethnicities.
Yeah.
Right. But
No,
actually.
I mention it because parents will have more motivation. Coming back to my first
Okay.
one.
So we do have race in the data, right? But it's still mainly whites. There's a significant portion of blacks, right? So these guys were born in like the 1930s, 40s. There's very few people who are not black or white or black. Okay? And then we have some Hispanics and some Asian, but that's a really small minority. Okay? So I wouldn't be able to look at like the Asian tiger moms or things like this. Yeah. Right, so the main idea of the paper is just how to separate the selection from the causal effect. Right? So basically, how to separate the fact that the parental state is correlated with this learning ability, but also going to have a spillover effect by increasing your initial level of human capital. Right? So given the expression for schooling, right, you can easily show that the earnings equation is going to look like this. This is a very standard result if you've ever solved the Ben-Parath model, right, where x is just your potential experience. It's just your age minus 6 minus s. So your log earnings given an experience profile and a level of schooling, it's just some function of schooling plus log z, right, where this is going to be some constant described by your level of schooling and some kind of function that increases with x conditional on schooling. Right? So this means that, conditional on my log z's, right, my log earnings profiles have to be all parallel, right, because all that's going to change with experience is this component here. Right? So this is saying given level of schooling, my earnings just increase with x, right? And it applies the same way to everyone. And it also means that that function of how your earnings increase with experience is going to basically give you the alpha 1 and alpha 2, the returns to human capital accumulation. Right? Of course, that's all conditional on z, but I don't see z. Right? So this doesn't really help. But I do know that z is correlated with the parental state, right? Log HP, or beta times SP. Right? So sorry, I mixed up some parts of the slide. So whenever you see log HP, it's the same as beta times SP. Okay? I apologize for that. Okay? So if I just replace the log z here, assuming some kind of parametric form of correlation between the z and the log HP, you're going to get the same equation basically. So basically this is going to mean conditional on parental schooling, everything is going to go through, that the earnings level is going to be parallel, and the gaps between the parallelness is just going to give you this coefficient B2. But what is this B2? This B2 is basically the correlation between log Z and SP. So that's going to give you like the level of selection, right? So this is selection. It's not the spillover part. It's just telling you how is the HP correlated with the child Z. Okay? So if you run a Mincer regression like this, where you just take the log earnings of an individual, regress it on the individual's own schooling and the individual's parent schooling, that coefficient should just be all selection, okay, according to the model. Okay. Now, according to the model, though, I also have a relationship that dictates what I have a function that dictates what the relationship to my schooling outcome and my state Z and HP should be. Right? So if I look at the guys who chose the same level of schooling, that's going to also give me a structural relationship between what the relationship between Z and HP should be. Right? So then I can control for the selection effect. And again, if I just run a very similar looking Mincer regression, right? So these guys look exactly the same. But instead on a subsample of guys who chose exactly the same level of schooling, right? The interpretation of the coefficient is going to be different. It's going to capture the spillover, right? Because I'm imposing a structural relationship between Z and HP. Okay? So that's basically the simple identification idea that this paper is built on. Okay? So there's a bunch of equations. I think it's easier to look at it in a graph. Right? So basically what I'm trying to depict here is, okay, this pink oval is just a sample. Okay? And I'm trying to regress your log earnings on the parental schooling. Okay? And what I'm saying is that if you just do that for the whole sample, it's going to capture all selection, the correlation between the Z and the parental state. Okay? So that's what this equation here was saying. Right? Oh, sorry. On the other hand, right, since the Z and HP, right, also determine the length of schooling you're going to get, and if I look at those guys who just chose the same level of schooling, which is represented in the blue lines, right, so if I only look at those guys and do the same regression, right, I'm going to get the spillover effect. Okay? So that's the idea. And here you can also see that the spillover is going to have a negative effect on schooling, right, even though it has a positive effect on earnings, because the higher my spillover, the higher the parental state is, right, the lower the choice of schooling is going to be. Okay? That's the structural relationship.
Do the cost of schooling depend on parental human capital?
Does the cost of schooling
depend on parental human capital? So
I mean, only endogenously, but not exogenously.
You might imagine that if you have more educated parents, it might be easier to do, to go through schooling because you've got more support, more knowledge in the home, and so on. So go the other, so if I understand your story is you start with a higher level of human capital, so you don't need to invest as much on your own, so you invest a bit less. But if human capital accumulation, if human capital of the parents actually make it less costly to go to school,
right,
then it's going to go the other way. It might be, I don't know if it's identifiable, but it might be important to take that into account. It's not the same for a kid with really, let's say, illiterate parents to complete high school vis-a-vis a child with 2 PhDs.
But in terms of just finishing like a length of schooling, right? So the children are still heterogeneous in terms of their learning abilities.
Absolutely.
Right? So the additional length of schooling will be cheaper for the guy with the high ability, who will tend to have high human capital parents. Right? So that's the only dimension we have. We don't have probably the more direct effect you're thinking about.
Yeah, but it might.
No.
I think these two effects.
These are probably separate, right?
I don't think you can aggregate them into one thing.
Okay. Let me think about that more. Okay. Okay. So that's the simple model. That's almost it. And in the end, I just have to explain a little bit about how we model the taste heterogeneity. But before that, this is the data that we use, right? The HRS sample of males born between 1924 and 1941, males, because this generation of females, not many of them have so much of an earnings history. And we also use the older cohorts because we want to capitalize on the endogenous schooling decision. Right? So if you look at data nowadays, it's mainly about going to college or not, or even if you just graduate college and get a master's degree or not. Right? But we want to have kind of somewhat of a continuity of years of schooling outcomes. Right? This is also why the empirical literature that looks at compulsory schooling laws, they're usually looking at much more previous generations, which is why we want to use the HRS cohort. Another kind of collateral advantage that looking at this cohort gives us is that we're kind of avoiding the period when there was like this huge rise in the education premium post-1980s. Right? So for this generation, they would have been less affected, right, by the future huge rise in the college premium. Right? So what the advantage that we have is that we're using the HRS data, right? But not me, but Ananth has access to the Social Security earnings data, where he can match the Social Security earnings data to all or not all, but most of the individuals that you observe in the HRS. Right? So in the original HRS, you only see like what happens during their very old age. By matching with the Social Security earnings, we can get almost perfectly their entire earnings history. Right? So after doing some cleaning, in the end, we're looking at about a little bit over 5,000 males. Right? For the sake of time, I'm going to actually skip the summary statistics. Okay? And just tell you what the data looks like. Okay, so what I'm plotting here, first is just to show you that the earnings profiles by parental education indeed do look parallel. Okay? So this is in order of parents' level of education. Right? So according to the model, they should be parallel, and indeed they are. Right? So this is without controlling for anything. I'm just taking the average of these guys' earnings for same level of parental earnings groups. Okay? And then if you control for schooling, as the model would tell you to do, right, the gap shrinks a bit. Right? So that's the part that you can explain the earnings differences by own schooling. And this is the part that you can explain by parental schooling as selection. Okay? So this is the effect that a high human capital parent or high educated parent has a more highly educated kid, and that's why that kid has higher earnings. Okay? So that's this effect. Right? So how do I get the spillover effect? Right? So according to the intuition from the model, you're supposed to look at only those guys with the same length of schooling. Right? So now what I'm doing is I'm just segregating children into different schooling bins. I'm going to look at guys below 12 years of schooling, right, and exactly 12 years of schooling. And in the next slide, I'm going to also show you something similar with guys with more than 12 years of schooling. Okay? So what you want to see here is that because what I want to show here is that, first of all, indeed, when I only look at those guys with low levels of schooling and then differentiate them by the level of their mom's schooling, right, there is a difference that, almost a parallel difference that seems to persist throughout life, and also for those guys with higher education. Right? And what's also more important for this very simple model is that the gaps between these two lines has to be similar in magnitude, right? Which they are. I mean, this is just a visual representation, right? So we do some formal econometric tests as well, right? But the model implies that these gaps should be similar, in which they seem to be in the data, right? So I do the same thing again for, okay, now this line is the same, as this blue and red line here, and I compare them with guys with higher levels of schooling, right? And at the higher levels of schooling, we don't have as much data, so the lines are less smooth, but you can again see that the gaps between guys with same level of own schooling but different levels of mother schooling have similar gaps in the earnings profiles. Okay? So basically what are we doing? We're trying to identify the row from the first, from this graph, and the news from these graphs. Okay? So I'm going to just run first empirically before doing directly estimating the model, an estimation of these very simple Mincer regressions. Okay? So like I said, we are assuming that parental human capital is just a very, very simple means regression of the parental schooling. That's all we observe of parents in the data. Okay? So these parents were born like in like 1900 or before in the US. Okay? So we're going to do two types of regressions that look basically the same, except that for this, we're running this on the entire sample, and for this, we're running it on individuals with similar levels of schooling. Okay? And I'm looking at the same coefficient, the coefficient on mom schooling. Okay? So what do we get? I mean, I ran, not millions, but hundreds kinds of different regressions. Right? So we can discuss the details if you want afterward. Right? But basically what you get is that the coefficient on mom schooling is consistently about 1.7%. Okay? So this is the reduced form effect of 1 year of mom schooling on children's earnings. Right? So
Uninstrumented, just a raw correlation.
this is just the reduced form regression, reduced form relationship. Yes.
So how much variation in maternal education do you have?
It was in my summary statistics, but
So these are women who went to school in the late.
Sorry?
So these are women who went
Right.
to school like more
Yeah.
120 years.
But actually, in the early 20th century, women in the U.S. went to school more than the men, which was actually kind of surprising to me as well. But that's what the data says in this paper. And in the HRS, you can also see that if you look at like the census or some other data sets presented by like Golden and Katz, these people, it's kind of a surprising thing. It's very similar, right? But on average, women actually went to school longer. And we did this same thing with dads as well. It turns out that if you do dads, you do see kind of a similar significance, but once you include both mom and dads, it's really just the mom that matters. That's why we kind of chose the moms. Right? That's in the more regressions, but I won't go there. Okay? So you see that the reduced form effect of mom's education on own earnings is about 1.7%. According to my structural model, that's all selection though. Right? So of course, this equation itself is just reduced form. According to my model interpretation, it should be all selection because I'm looking at the entire sample. Okay? So just keep in mind this number, 1.7%. Okay? And now just to kind of correspond with the model, right, I also split the sample into guys with the same level of schooling or similar levels of schooling. Right? Run the same regressions again, separately for each group. Right? And you can see that, where is it? These coefficients are pretty similar. It's a little bit lower here, right? But still, it's similar in magnitude throughout all the education groups. The weighted average is about 2. It's very similar to the 2%. It's very similar to the 1.7%. And according to the structural model, right, this is what would be counted as a spillover effect or a causal effect. Okay? So I'm not claiming that this is the actual selection or causal effects. Right? This is just, according to the simple model, that's what it would mean if I just run these regressions in the data. Okay? So to compare with the 1.7% and 2% that I get from the reduced form estimates, we're going to do just a GMM estimation of the original model. Okay? That includes also taste heterogeneity. Okay? So the lifetime earnings component is going to be the same, except that we're also going to estimate different exponents for the schooling and work phase human capital production functions. And we could do a continuity. We can still make the schooling choice continuous, but for the sake of being realistic, we're going to kind of discretize it. You don't ever see in the data that this guy went to school for 8.23 years. Right? We could do it for 1 year, and we did, but that's not going to really change the results much. So we're going to stick with 6 discrete schooling levels that vaguely correspond to high school or below, and some college and above. Okay? This is just the years of schooling. Right? So now the optimal schooling choice problem becomes choosing an S within these 6 values, right? Instead of choosing a continuous variable. Okay? Right? So the most important thing that's different in this estimated model is the inclusion of the taste heterogeneity. Right? So this is going to capture basically everything that is not accounted for by economic motives. Right? This is just going to be all purely non-economic motives. Right? So this psi is going to be correlated with, is also going to be correlated with the parental state and the child's own abilities. Okay? But notice that what it's going to do is, if your psi is high, right? This just adds to your utility at the beginning of life of choosing a certain schooling level. So if the psi is high, you want to go to school, right? So it doesn't directly affect your earnings, right? But it will indirectly decrease your earnings because you're staying in school longer at the detriment of delaying entry into the labor market. Okay? So there is an indirect effect on decreasing earnings, even though there's no direct effect. Okay? So these are, just some parametric assumptions we make for the estimation. We're going to assume some kind of parametric relationship between the z and the SPs. We've also done this non-parametrically. It wasn't very different in terms of the results, but it was harder to present, so we stick with the parametric form. Okay. For the psi, as most microeconometricians, which I am not, we're going to assume a generalized extreme value distribution. Right? So they're nested. So within each nest, we're going to have a correlation of 1 minus, I think this is zeta h, and 1 minus zeta c. Right? So the high school choices and the college choices are correlated. Right? And given that, you can just use the standard techniques to get the conditional choice probabilities of which schooling level you're going to attend, right? Given the present discounted lifetime earnings value. Okay. So with that model, we're using just we're going to look at a population of individuals who are solving the optimization problem that you saw in the very beginning. And we're going to try to match these moments that we have in the HRS. Right? So these are just basically the life cycle earnings profiles that I showed you in graphs earlier. Right? And this is just the share of this population, right? Children with moms with 5 or more years of schooling, and their own schooling is more than 11 years. Sorry, let me rephrase. This is the fraction of children with moms whose schooling is 5 or more years attain 11 or more years of schooling. Okay? So, and then basically these are all the moments that we want to match or target, right? Including also some intergenerational schooling regression coefficients in reduced form, and also the Mincer coefficients. The beta 1 is the coefficient on my own schooling. The beta 2 is the coefficient on parent schooling. Right? So we want to match these two things as well. So in total, we're going to have 18 parameters and 57 moments. The model is pretty simple, so you can just use standard GMM techniques and get asymptotic standard errors. And thanks to Joanne for helping me getting them. Right? And you result in these parameters. Without going through all of them, let me just point out the important ones. Obviously, the most important ones is the spillover parameter and the correlation parameter. Okay? So I mean, these magnitudes don't really mean anything, so you shouldn't put too much value on the fact that this is much larger than that guy. Okay? So we're going to go into interpreting what these magnitudes means in the following slides. Okay? But it does seem to just still give you a sense that this guy is going to have an effect, right? And you want to compare how big this effect is going to be compared to that. Okay? Secondarily, right, although we did assume that your own ability can also affect your initial level of human capital, that parameter turns out to be pretty small, right? It's almost insignificant, and the correlation of your taste with your own ability also turns out to be very small compared to the correlation of your taste with your parental state. Okay? So this basically means that whether or not you want to go to school, independently of trying to maximize your lifetime earnings, so you have a much higher desire to want to go to school if your parent went to school longer. Right? So I think this is related to what some people raise. Right? It's not necessarily because the parent wants you to increase your earnings. Just having a highly educated parent induces the child to go to school longer. Okay? This is what this guy means.
The cost is the way you do it, you have to put it in base. The costless basically says cheaper.
Yeah, no, I agree. Right, that would be a third dimension, and we'll have to look at that. I mean, I think actually that we maybe can build in, so I will think about it. Yeah. Right, so these are the current results we have. So basically what I want to show first in this first series of table is what is kind of the implied effect of having these nu in the row. Okay? So just very simplistically, what I'm first going to do is just set them to 0 and just see what happens to the population means. Okay? So what happens when you assume there's 0 spillovers, right? So if I set this guy to 0 in the model, there's by definition no spillovers. Right? The observed schooling, the intergenerational schooling relationship is going to be higher, which should be expected because in the model, the structural relationship is such that if you increase mom schooling, the children will cut back on their schooling. So if I get rid of that, it's going to go back up. Okay? And if I set this back to its original estimated value, but instead shut down the correlation between parental states and own abilities, excuse me, it's going to decrease this a little bit. It doesn't really have much of an effect, but where it has the biggest effect is as kind of the reduced for kind of the simple model intuition delivered, it's going to have the biggest effect on the beta 2 coefficient, right? On the population beta 2 coefficient, right? This is the coefficient of regressing own earnings on mom's schooling. Right? And according to the stylized model, this should be actually exactly 0, but you can see that this is mainly, in the estimated model, it's still mainly affected by the rho. Okay. And what's the role of this taste heterogeneity? Like I said, this correlation of taste with own ability doesn't really do much. Right? What really matters is the correlation of taste with the parental state. Right? And it actually plays a pretty big role. Right? So basically, this guy is saying without this, actually you should see a negative relationship in the schooling patterns, because without this, all you're going to have is a structural relationship where children of higher human capital parents are just going to cut back on the schooling, so it's going to be negative. Right? So why do you see, what makes it positive? It's just that this correlation is very high. Okay? So that's basically this is just showing you that the intuition that you get from the simple model and also what you think about taste is borne out in the estimation. Okay? So now in this one slide, to increase understanding of the intuition developed in the simple model and how that's related to the estimated model, I'm just going to compute these beta 2s. Remember, this is, that's the important coefficient. That's the effect of parent schooling on children's earnings. Right? And according to the simple model, that coefficient should be exactly this. Right? While if I tried to estimate the spillover and only looked at the children with the same level of schooling, it should be exactly this. Right? So these are the results you saw for these coefficients in the simpler model. Right? So suppose I just forget about the GMM estimated model and just use my GMM estimates, but instead believe in the simple model and plug them back in. Right? So what should you get? You do get that actually, whether you use your GMM estimates or just regress directly on the data, that the magnitude is pretty similar. Right? So in the data, it was about 1.7. Here it's about 1.3 to 1.9. So why is that? Well, although I included some taste heterogeneity, right, Z is a variable that not only increases my earnings, but also increases my schoolings. Right? So even though I include taste heterogeneity, the effect of the Z is still there. Okay? So what is the effect of increasing Z? It's going to increase both schooling and earnings. While what is the effect of the taste heterogeneity? It's going to increase schooling but decrease earnings. Okay? So this is less effective than this guy, right? Because the spillover works exactly in the opposite direction. The spillover decreases schooling but increases earnings. Right? So if I ignore the fact that there is actually taste heterogeneity in the sample, right, you're going to incorrectly infer that the beta 2 has to be really large. Okay? So this is just, maybe it's a little bit confusing. It's just the difference between the reduced form regression interpretation of the model versus the GMM version of the model. Right, so now I'm just going to show you two simple counterfactuals, and I'll be done, and we can go have lunch. Okay, so like I said, the first thing we want to do is just what's going to happen if we just forcefully assume that all the parents had one additional year of schooling. And the second thing I'm going to do is what's going to happen if we just put a minimum compulsory level of schooling on the parents. Right? And I'm going to show you this in 5 different ways, because depending on how I control what happens. The first is suppose that the child's level of schooling stays the same, and you just increase the parent's level of schooling. Okay? The second is right? I'm going to increase the parent's level of schooling, right? But the model does dictate a relationship between the parental schooling and the child's ability and taste for schooling. But keep this constant. Don't change it with HP, right? So this is going to be kind of the IV estimate, right? Because you're not changing the underlying distribution of other variables while increasing the HP. Right? Now from there, I'm going to let the taste change with HP. I'm also going to let the abilities change with HP. Right? And then if I let them all change, that will be the observed reduced form outcome. Okay? And what you want to see here is that, if I fix the years of schooling and just increase mom schooling by 1 year, this is all on average, right? Children are going to cut back on schooling, right? This should be expected. That's the structural effect that I have in the model. Okay. Now, if I let abilities vary with parental state, right? So higher human capital parents will tend to have higher abilities, right? So they'll start to go schooling a little bit more. The real kick comes when you let the taste vary with with the parental schooling, right? Which is when it becomes positive and close to the reduced form relationship that is observed in the data. Right? What happens to earnings? If I don't change the length of schooling, but only the parent's level of schooling, you do see a 0.7% increase in own earnings. But if you let the child adjust, basically just cut back on his length of schooling, that increases close to twofold to 1.2%. Okay? And the rest of the interpretation is the same. Okay, so basically what this means is that the isolated causal effect of increasing parental schooling is about 1.2%. Right? Adding the selection effect results in about 2.5%. Right? So these magnitudes, the increase from here to here is similar to this magnitude itself, so they're comparable. Okay? Which is kind of irrelevant of the observed the reduced form effect, because once you take into consideration the heterogeneity in taste.